Hi, my name is Makura Agobakedija. So today I will be talking about network deception and detection, which is our project two with my team number 9. So basically, I'll be telling exactly what I've done during this project. So these projects demonstrate a multi-layer honeypot system designed to detect reconnaissance, credibility, harvesting, and scamming activity within a network. So the honeypot operate as a deceptive target, enabling the collection of attacker behavior without risking actual system. So throughout this presentation, the architecture, implementation, further and security benefits will be discussed. So the goal of the honeypot system is to identify malicious actor early during reconnaissance. The system uses multiple deception layers to trick attacker into interacting with fake services. So these interactions are logged for later analysis. The module include fake port, SSH banner emulation, SSH brute force capture, and ICMP-ARP responses. So each designed to mimic real network behavior convincingly. So point one, dedicated honeypot machine run all decoy model. So one isolated machine run all fake services. Keep attacker completely away from real services. Attackers have no path to actual infrastructure. Point two, attacker interact anonymously with fake services. So attacker think they found a real system. You see authentic attack behavior. You learn real threats, not the theoretical one. Point three, unifying logging backend store all events. So every event gets recorded in one central place. Complete audit trail for investigation, easy to find and analyze what happened. Point four, automated firewall engine react to malicious behavior. So system responds automatically to instantly. So no waiting for human approval. Block attacker 24/7 without your team involvement. Bottom line, honeypot isolate threats, teach you about real attack, keep evidence, and automatically defend you all at once. So the main objective focus on deploying realistic decoy services, capturing attacker behavior and generating intelligence. So another objective is to centralize uh, of logs support easy analysis. So additionally, the system adds automated firewall blocking that acts on malicious trigger. This creates a full cycle of detection, recording, and response. So honeypot act as early warning system. They provide valuable insight into attacker method and tool without exposing real access. They are cost effective and reduce noise by focusing only in one malicious traffic. They also provide educational benefits for learning about network security and threat behavior. This So this architecture consists of two components, an attacker and the honey machine. The honey, so this architecture consists of two key components. So an attacker and the honey pot machine. The honey pot exposes several fake services that resemble real system. So each module is isolated but logged to the same file. When attacker performs scam, brute force obtains or ping, this module respond realistically and capture data. The automation engine evaluates its behavior and block IPS when necessary. So this diagram show the attacker machine interacting with multiple honeypot early um, entry point. So fake port capture probe, fake SSH capture authentication attempt, and ICMP responder handle pings. So all logs are funneled into the same log file. So a trigger automation monitor this file and injects firewall rule to block offending IPS. This creates an end-to-end deception and defense cycle. Um, Features one, multiple protocol deception. How a honeypot can mimic multiple protocol at the same time. Catches attacker using port 22, 3389, 445, 5900, and more. Simulate different services at a time. Make a trap more realistic, effective. Features to centralize logging. So every action an attacker take gets recorded in one place. Logs are organized and easy to read. Clear logs equal faster decision making. Feature three, low resources usage with great visibility. Lightweight system that doesn't slow down your network, doesn't consume massive server resources, still provide complete visibility into all activity. Best of both worlds, efficiency plus insight. Feature four, highlights customizable architecture. So not locked into one rigid setup, can customize to match your exact environment, tailor it to your specific security concern, flexible for different organization need. Feature five, future integration and expandability. So this can be integrated with different security tool in the future. So this model exposes multiple fake services on commonly attacker ports. Attackers scanning the network will see this port as open and obtained connection. The honeypot log this obtained as indicator of reconnaissance or exploitation attempt. It mimic low-level protocol behavior but does not expose real services. So this module stimulates the first step of an SSH connection, sending a binary. Attacker often use binary grabbing to identify SSH version. The honeypot responds with a legitimate logging binary. Any client connecting just to fetch the binary is logged, which helped detect reconnaissance or automated scanner like Nmap and Mascam. This model capture username and passport sent during SSH logging attempt. It does not provide shell access, but simulate an authentication system. Every attempt, including repeating brute force attempt, is logged. This helps detect botnet, brute force, malware, and human attacker trying to common credential. Attackers often perform ping swing or ARP scan while mapping the network. This module responds to those scans on unused IP addresses create the appearance of active host. These responses allow detection of lateral movement or network discovery obtained by attacker already inside the network. All requests and responses are logged. So Honeypot's automation engine, which is the core defense component of a system. This engine continuously monitors all honeypot log in real time and classify events such as port scam, SSH, logging attempt, and repeated ping activity. It uses time spent based tracking to determine whether an IP is behaving maliciously. So once the IP across predefined threshold, such as three-port scam within a minute or multiple SSH brute force attempt, the automation engine immediately apply firewall rule to block the source permanently. The engine use both firewall and IP table, ensuring resilience even if one machine is invulnerable. The automation significantly reduces the time an attacker can speed probing the environments and add an active response layer on top of our deception infrastructure. So the unified logging system is the key component of the project. Instead of storing log in scattered location, every honeypot module write a single file. This makes the system easier to analyze and ideal for forensic timeline. The log format include timestamp, source IPS, and module identifier. Let me walk through what happened when an attacker finds their way to one of our honeypots. So first, they scan the network looking for targets. Think think of this like somebody checking door to see which one is unlocked. Second, they discover what look like an open port and services. Think that appear valuable. These are fake though. We make them look real on purpose. Third, the attacker connect to what they think is a real system. They don't know it's actually a honeypot, our trap. Fourth, it is important, this is the important part, every single action the attacker take gets logged. We record everything we do, everything they type, every file they touch. And fifth, this is critical. No actual harm happened, no real system are damaged. We have complete isolate these traps so attacker can jump to our real infrastructure. They are sacks in a contained environment. Now here where our automated defense kicked in. Step one, our automation engine is always watching the honeypot log. It constantly scanning for suspicious activity 24/7, no break. Step two, when activity come in, our system check it again, our security rule. We have programmed it a specific pattern that we know are dangerous. Step three, the moment something match one of our alert rule, the response system automatically triggered. There's no waiting for a human to notice. It react instantly. And step four, the response mechanic take action right away. So it block that attacker IP address on the firewall, or if needed, add them to our IP block list. The attacker gets cut off immediately. So the honeypot strengthens the network defense posture by increasing visibility into malicious activity. It helps identifying attacker long before they react valuable target. The system also offer forensic value by recording all interaction. This enhances the organization detection and the response capability significantly. Because all modules are lightweight, Honeypot has minimal performance impact. Python-based services are efficient when handling small dummy interaction. The system avoid exposing real data and use isolated process for safety. So it is a highlight, reliable, and suitable for a long-term deployment. So, future enhancement. So, the system is designed to be extendable. So, future improvement could include dashboard for visualization or integration with SIEM platform. Machine learning could classify attacker pattern. Web-based interface could simply management, and even like malware sandboxing could be added to capture payload attacker. So that is what the part have done in this project, and thank you so much.
Hey everyone, my name is Eugene Lee. The part I did for this project is to implement a low interaction honeypot system using the Cisco Packet Tracer. And for the network architecture, so I have a honeypot switch, a honeypot router, a honeypot server, and a attacker PC. And I already implemented all the IP addresses, the configurations for each devices. And for the attack simulation, the attack simulation will demonstrate how an attacker will discover and interact with the honeypot services. So the first way is host discovery. So the attacker first discovers live host using the ICMP ping. So let's uh, see how we can do that. So if we ping, yeah, and we can see that the uh, connection between the attacker's PC with the servers is successful. And the second way is through the web service. So the attacker will access the web server to gather information about the target. And we can see we can enter uh, the servers from the web server. And lastly, is the FFT brute force simulation. So this is the attacker will attempt to log into the FTP server using the common credentials. After several failed attempts, the attacker will successfully guess the password, and this demonstrates how the honeypot can detect and log brute force attacks. And so let's And yeah, this is how um we how the FTP brute force simulation works. And that's all for my part for this project. Thank you.
Everyone, for this demonstration, I will show how we design implements detection, monitoring, and automated response in a simulated network environment using Packet Tracer. We isolate a tracker using VLANs, collect logs through a syslog server, and automatically block malicious traffic using router ACLs. Our first step is VLAN segmentation. The honeypot and syslog server are in VLAN 10, while the attracker is placed in VLAN 20. This forces the attracker's traffic to pass through the router, enabling us to enforce ACL blocking. Next, the router is configured with sub-interfaces for each VLAN. This allows layer 3 routing between the honeypot network and the attracker network. We also use a syslog server to simulate centralized logging, similar to the ELK system in the original Python implementation. The router sends its logging messages directly to this server. Before applying any blocking rules, the tracker can successfully reach the honeypot. Let's verify this connection. As we can see, the honeypot is reachable at this stage. Now we simulate the auto-blocking functionality. Once the tracker is identified, we apply an ACL rule to block all traffic from the tracker's IP address. This ACL denies all packets from 192.168.2.50, the tracker's address. Now let's verify that the ACL has been successfully applied. And here we can see the denied entry for the attracker IP. Now the attracker attempts to reach the honeypot again, but this time the router should block the traffic. As shown here, the result is destination host unreachable. This indicates that the router is actively redirecting the traffic, making the honeypot unreachable from the attracker network. This confirms that our automatic blocking mechanism is functioning correctly. In addition, the router sends log messages to the syslog server, allowing centralized monitoring of block activities. If needed, we can remove the ACL to restore connectivity, representing manual override or false positive handling. Now the attacker can reach the honeypot again. Alright, so to wrap things up, what we just walked through is the full circle of our detection and automated response systems. The tracker could initially reach the honeypot. The router detected and logged the traffic, and the ACL automatically blocked the attacker's IP. The syslog server collects all related events, and once blocked, the tracker saw destination host unreachable. So overall, this demo shows how the network can automatically detect malicious activity and respond in real time, just like real intrusion detection and response systems.